Hi Year 11. This is the third lesson for the topic of probability, and it's for the International Baccalaureate courses Analysis and Approaches and Applications and Interpretations. And in this lesson we're going to cover conditional probability. So conditional probability involves calculating a probability given another event has occurred, and this is the formula that we use. This is probability that A occurs given B has occurred. It's equal to the probability of A intersection B divided by the probability of B. Let's look at an example. A group of 25 students either studies chemistry or biology or neither. It is found that 15 study chemistry, 14 study biology and 6 study only biology. All right, let's draw up our Venn diagram. What do we have? 6 study only biology, so that goes in here. We know that 14 study biology altogether, so 8 must be in here in the overlap. And we know 15 study chemistry all up, so 8 from 15 gives us 7. Quick total, 7 and 8 is 15 and 6 is 21. So from 25 that leaves 4 outside of those two circles, so 4 don't study chemistry or biology. All right, here's the question. Find the probability that a student chosen at random studies chemistry given that they study biology. So it's a conditional probability. Now you can use the formula, but it's a bit of overkill. Just use your intuition. So given they study biology is these 14. So out of these 14, what's the probability they also study chemistry? Can you see it's 8 out of 14? Okay, so it's really easy just to do it without the formula, just by looking at the diagram. Now you've actually been doing conditional probability for quite some time, but you didn't know it because it's in those tree diagrams without replacement, and it's actually here. Do you remember how when you had to figure out what this probability was, you had to take into consideration what had happened before? That's exactly what conditional probability is. So this is the probability that blue is drawn on the second go given it was drawn first. Here's the probability that white is drawn on the second go given blue was drawn first. Let's have a look at a question. Find the probability that blue is drawn given white was drawn first. Where is that, do you think? White was drawn first. Here it is here. So the probability of blue given white was drawn first will be 3/6. But of course sometimes we do have to use the formula because we're given no context, and the formula is given for you in the formula booklet. So find the probability of A intersection B if the probability of A given B is 5/12 and the probability of B is 3/5. Alright, there's our formula. Let's substitute it in, and the probability of A intersection B must be 5/12 times 3/5, which is 1/4. Now you might be given a question and it'll seem like you don't have enough information, and in this case return to the Venn diagrams and see whether you can figure out the bits that you need. Here's an example. You're given the probability of A union B is 0.8 and the probability of A intersection not B is 0.45. Find the probability of A given B hasn't occurred. So let's start with this one. This of course looks like this. A or B or both, that's 0.8. So we could easily work out the probability that neither A nor B occurs. That must be 0.2. That could be useful. Let's have a look at this one here. That's this pattern here. So this is 0.45. If I have a look at these two patterns, I can easily work out the probability of B. It must be 0.8 take away 0.45. Wouldn't you agree? So the probability of B occurring is 0.35. Alright, let's have a look at our formula. So probability of A given B doesn't occur is equal to the probability of A intersection not B over the probability of not B. Alright, what have we got? We have the numerator as 0.45. Probability that B doesn't occur is 1 take away the probability that it does. So 1 take 0.35 is 0.65. So that's 45 on 65. Divide top and bottom by 5, we get 9 on 13. This question, if you were given it, would probably be in the non-calculator part, so you'd need to do a bit of fraction work. So I'm going to finish off this lesson by talking about Pollier's urn, which is a statistical experiment which you might find interesting. Here's how it goes. An urn contains a number of red and blue balls. One is drawn at random, its colour is noted, and then it is returned to the urn with another ball of the same colour, like this. So I draw a ball out and say it's red, so I'm going to add another red ball and return both of those to the urn. So if initially there are R red balls and B blue balls, what's the probability that the first ball drawn is red? Well, the number of red balls is R, and the total number of balls is R plus B. So the probability must be R divided by R plus B. Now here's the curious thing. The probability of drawing a red on the nth turn is also R over R plus B. And I'm denoting R subscript n as the event that a red ball is drawn on the nth turn. Now how can that be? So let's have a play around with it and see if it's true. Let's put some numbers in. Suppose initially there are 7 red and 7 blue balls. And that means that the probability of red on the first turn must be 7 over 14, which is a half. So we need to show that the probability of red on the second turn is going to be a half. Now it's really easy to say, oh, the probability that it's red on the second go will be 8 on 15 or 7 on 15. But it depends on what the colour of the first ball was. You see, it's 8 on 15 if the first ball was red, and it's 7 on 15 if the first ball was blue. And so we're going to need to use conditional probability. This is actually what it's going to be equal to. The probability that the first ball was red multiplied by this conditional probability. It's red on the second given it was red on the first. So that's 8 on 15. Or plus the probability it was blue first multiplied by the probability that's red on the second given it was blue on the first, and that's the 7 on 15. So substituting in, the probability that's red first is 7 on 14, or blue first is also 7 on 14. Tidying that up, we get 105 on 210, which is indeed a half. So here's the challenge. Can you prove it for the nth case? Can you prove that the probability that the ball is red on the nth term is also equal to R over R plus B? So I'll leave that with you. By the way, this would make a really interesting exploration if you haven't thought of something so far, because there are links between Polly's urn and cancer research, of all things. So there's an idea. So that's it for this lesson. Our next lesson is on independent events.